Good afternoon and happy holidays. We're on our final day before, Christmas or whatever holiday that you may celebrate. So exciting stuff. So I liked opening up with a quote last time. And so I'm going to follow suit in this discussion with a quote from Nikola Tesla. So that's the 19th, 20th century inventor. And he said, "The present is theirs. The future for which I really worked is mine." And of course, I would change that and say the future is ours, right? We're a team here. We're working on microtech. And whether it's Justin, Rich, Dean, and I, or you as the investor, we're all team here to see this succeed. So that's going to be the topic of today, really, is the technology, right, and developing for the future. So the technology that we're creating here at mIQroTech is set to make the world a better place. And when we're talking about our technology today, we're not going to go into all the very proprietary stuff that we can't discuss, right? Don't want to give away all of our secrets. But giving you the fundamentals of the device itself and the artificial intelligence, neural networks inside, I think will give you a better idea of what's actually going on, and really speak to what we're achieving here. So before we begin, let's define a few concepts. First of all, there's IoT, so that's Internet of Things. And that's typically defined as the interconnection with the internet and computing devices embedded in everyday objects. So we're changing that everyday objects and changing that to pipelines. So the interconnection via the internet and computing systems embedded in pipelines. So next we'll define artificial intelligence, right? And that's the development of computer systems that perform tasks that are typically reserved for human intelligence. And the great thing about artificial intelligence is it doesn't replace human intelligence, it augments human intelligence. It gives humans insight to things that we can't see, little changes or patterns that human brains are just not capable of catching, right? They are able to see all the data all at once rather than a narrow view of it. So back to our devices, we're capturing what we call the six-factor analysis. And although our devices measure a variety of variables that each have multiple layers to them, the primary variables that we watch for are density, which is great for finding air pockets, debris going through the pipeline, other contaminants, pressure, which that's for overpressure or underpressure. So let's say there's an event where all of a sudden there's a pressure spike that could potentially rupture the pipeline. The metal's not made for that type of pressure. That'd be an event that we want to see. But under pressure events are equally as notable because that could be there's a potential leak. Vibration is great for impact, or let's say there's if this is an underground pipeline, let's say there's a vehicle going over the pipeline that shouldn't be there. You can do some intrusion detection with that as well. Temperature is another variable that we monitor, and that's to measure the formation of hydrides, which are like ice or any form of water vapors that form on the inside of the pipe. So keeping the temperature within a specific range can help minimize that and minimize the effects of it. Geopositioning is one that we monitor, but that's not something that we actively monitor. We get it a few times, and if your pipeline's moving, it's a really bad day. So we use the geopositioning to compare positions. So if we're getting a pressure reading at point A and see a different pressure at point B, well, how many branches are there? Does that pressure difference make sense? And that's where the artificial intelligence comes in. Are we used to seeing those pressure differences, or do we go from, I'm going to make up numbers here, but did we go from 120 psi to 60 when normally we see 120 psi the whole way through? That would suggest there was some incident that happened. So that's important to look at. But one of our more proprietary measurements is what we're terming as metallic wash. And it's so special because no one else is doing this. And what we're seeing is we're actually measuring the metallic particulates flowing through the pipeline. What we're able to address from that is the corrosion rate of the pipeline. And what data is suggesting is that 60% of all pipeline failures are corrosion based. So that is one of our most critical factors that we watch, and no one else is doing it. And so by measuring that and being able to predict the corrosion rate and say, okay, you're going to be down to this much metal in this many months, this many years, and you're running at this pressure, being able to draw those conclusions, we can do some insane analytics. But one of the big things that makes our device, a lot of our competitors, is studies found that tapping the pipeline, so boring a hole and attaching a transducer to the inside the pipeline, that can be a source of leaks, right? You're putting a structural defect into the pipeline. So it's almost ironic that you're tapping into the pipeline to monitor risks. To avoid this entirely, we collect all of these variables, the 6 variables I just went through, externally from the pipeline. So we don't tap into the pipeline. There's no intrusion on the pipeline itself. So our methods for capturing this data externally, our experimental partners have called magic, right? And there's actually, I'll hit you with another quote by Arthur Clarke: any significantly advanced technology is indistinguishable from magic. And I think that's so true with what we're doing here at mIQroTech. Is it really is magic if you don't understand the science behind it. And that's why I'm passionate about talking to you about this, because once again, there is a whole lot of science, and all the science is backed by peer-reviewed research. And so this is so cool that we're able to bring this to the market, and to a market desperately in need. So anyway, let's talk about the AI, the artificial intelligence, right? So we use a group of what's called neural network technology and to analyze our data. And what that is it's almost a decision tree where data goes in, it's compared to findings from previous data points, some mathematics that we injected in, and also percentages and analytics that we've already found. And then it's compared to analytics that the artificial intelligence has already found. And then out the other end comes the decision that the AI is making. This is happening for every data point, and it happens multiple times over for every data point. And so what this means is that we're able to assess each and every piece of data that we capture individually, and then also, how it's compared to other data that we found in the past, and if it's normal, if it's not, if we've seen these in patterns before. And so we're really able to make that data talk. And so this technology paired together alone, it does a lot, right? AI is a hot topic in investing circles, and even in technology spheres, right? It's one of those terms where everybody's talking about AI, but very few people are doing it, right? When we talk about AI, AI is not just standard deviation mathematics. We start with that with our math because it's an easy place to start, but AI is actually making decisions. It's actually telling us what the data is saying. And it's more than even machine learning, right? Because machine learning is more basic than actual artificial intelligence. So a lot of these firms claiming that they're doing AI, I mean, it's a difficult thing to get into, and that's why it's, once again, exciting that we're getting into it. And IoT, Internet of Things, that's another hot topic in investing in technology circles. And it requires a skill set in both electrical engineering, some hardware programming, and so we put together a great team to get this job accomplished. So our technology is coming a long way. We just partnered with a DoD contractor to produce our circuit boards for us. So that's incredible. This is state-of-the-art technology. Actually, he went through how he can make sure that these don't malfunction. there was actually a crisis at, not this firm, there was a crisis that ended up making a missile misfire back in the, I believe, the 80s, he told me. But and that was due to lead-free components. And so we're avoiding those components in this technology to make sure that, you know, mishaps don't happen. So all around, guy's a genius, and really master at this. And we're having our electrical engineering forms now reviewed by a firm to just go over it, do some double checking of everything, make sure that, you know, everything's sustainable for very, very long service life. And after this, we're going to send it through the FCC, get everything cleared, and we'll be good to go for mass production. And you know, with the investors involved, you guys have been more than a blessing to us. We're over $90,000 now, $90,000. So on final stretch here to get this campaign maxed out. Let's do this, right? We're a team here. So talk, tweet, Facebook it, LinkedIn, you know, max out this campaign, because every investor dollar that we get here is going to the research and development and betterment of this technology, which means, you know, more value to the company as far as research and development goes, but also more impact on the environment. With better technology, we'll be able to prevent more leaks and really be able to make our impact here in this world. So once again, cannot thank you enough. Oh, I mentioned some big news last time that's coming up. Still need to hold off on telling you that, but January 5th, there's going to be a press release, and there's going to be more information coming out from me. So that's your spoiler alert. Stay tuned. But incredible things happening, and you know, keep it up with everything that you're doing. Thank you so much. We'll talk again soon. All right, bye-bye.